All right, we'll get the formal workshop started in just about 2 minutes. In the meantime, I'll make some announcements about soda. As always, we're looking for volunteers. We have a list of volunteers that we actually need to get back to. So if you have said you want to volunteer, UA and I will be contacting the group. And as an introduction, I'm Daniel Hitchcock. I am a software engineer at the metabolomics platform at the Broad Institute. The other co-chair and the co-chair of SODA. The other co-chair is Yue, who is sent me a cryptic message that he's dealing with California smog right now, but he is a postdoctoral associate in the Snyder Group. And so we'll be asking for some volunteers. We have openings for SODA workshops and meetups right now. If you'd like to join, present, or if you have any suggestions for if anyone has that would be great too. With that being said, welcome to the second SODA workshop. We have two speakers today who will be co-presenting hands-on training for the GNPS Dashboard and microbeMASST. Dr. Simone Zuffa and Ipsita Mohanty. Simone was kind enough to present this twice. First was over a SODA workshop or a SODA meetup where just went over the basics of microbeMASST, the rationale behind it, how it works. But today, along with Ipsita, was going to be a hands-on demonstration of the dashboards. With that, if anyone has any questions, this is only the second workshop we've hosted, so we're not sure if questions ever become overwhelming or clarification, but feel free to use the chat or raise your hand or just try unmuting the microphone and see what happens. I don't think it'll be too overwhelming. Also, if your microphone is unmuted and you're not asking a question, I'll probably mute you. I'll assume it's by accident and just remute the microphone. With that being said, if Simone and Ipsita, if you'd like to take over, and I'll stop sharing my screen so you can actually share yours.
Sure, thanks, Daniel. Yeah, I'll start. I'll give a brief introduction. As Daniel was saying, like, feel free to stop or ask question at any time since we are like a small group. Here, today we're gonna give you an introduction to the GNPS toolbox, basically for reanalysis public data, specifically focusing on microbial data, as I will also give like a brief introduction of how to use microbeMASST and hands-on. So in this QR code and this tiny URL, you will be able to find Google Documents with all links to this presentation actually, and a lot of other useful links. So even if people are going to watch this later online, they will be able to access all these documents. So they will be able to create, for example, a GNPS 2 account. So today I'm going to start and later also Ipsita will give an introduction of GNPS dashboard. But okay, wait a second. Let me open Slido. I just wanted to check with you guys a brief understanding what are you guys working on at the moment. So if you can scan this QR code, you will be able to interact with us. So if you take your phone, or maybe you can just use also your browser, you go to slido.com and you put this code, you can just tell us like on what type of data you usually work on, if it's LCMS data, NMR, GC, or maybe you are working with more like companies that are putting in different that they give you back tables that maybe it's a bit easier compared to the untargeted metabolomics that we usually work with in our lab. So I'll give you like just a minute to see. We have more or less 10 participants, so let's see if we can have everyone. So for now, everyone is working with LCMS. Okay, well, that's fantastic. So Obviously, spoiler alert, we will be working with the LCMS data, so this is perfect for us. The next question is like, um, if you are working with LCMS data, on which sample do you routinely acquire MSMS information? Are you running MSMS on all the samples or only on some of the QCs? You don't run MSMS, you just work with MS1 data. Obviously, you all said that you are working with LCMS data, so I don't expect anyone putting that you don't work on with MS data. Okay, so some people are acquiring only on the QCs. I'll give you one extra second, but seems that 2/3 of the people are acquiring MSMS data from all the samples like we do in our lab. Okay, some actually is more almost a 50-50. Interesting. So the next question would be, so have you ever deposited metabolomics data in public repository? If so, which kind of repository have you used the most? Are you depositing your MSMS data in GNPS Massive, metabolites, metabolomics workbench, or maybe other repositories that are out there, or you maybe have never deposited data online? Um, Okay, so there's a good split between GNPS Massive and metabolomics workbench. Fantastic. I'm glad to see that more people are depositing data. At the metabolomics conference in Osaka, we had almost 50% of the people attending the workshop that have never deposited data online. So it's great to see that people are depositing some data. So now we were gonna start with the workshop. So since I'm glad that most of you are working with, actually every one of you is working with LCMS data. So hopefully you know the basics. We cannot go through it because of the limited time, but in the documentation there are like, and in this presentation there is links to other documentation where you can find information on what LCMS data is, like how to convert from proprietary format to open source format like MZML, and how to create GNPS accounts. So in this case, also we will give you tokens to, if you don't have it already, to create accounts for GNPS too. So if you scan this QR code or you click on this link, you should be able to have the presentation. There will be a Google form where you can put on your information, your email, and then we will get back to you and giving tokens to create a GNPS2 account. As I was mentioning it at the beginning, you can also do it later when this presentation will be uploaded on YouTube. But with that, let's dive in the workshop. So I'll just give the floor to Ipsita that will show you how to use the GNPS dashboard.
Awesome. Thank you. Thank you, Simone. And good morning or good afternoon to all of you, depending on where you are joining us from. Give me 1 minute to start my slides, but now may be the time to get onto your laptop computers that you have, because we'll start with the hands-on part of the workshop. Okay, so I have my slides up. Sharing. So first, I'd like to introduce the data set that we all will be using for the hands-on part of the workshop. I'm hoping you all can see my slide with that cute little cat on there. As this actually happens to be one of my favorite data sets, because not only did we discover some new molecules from this data set, but when I first heard about it, that I'll be working with some samples from cats, I was expecting some fecal samples from domestic cats and these cute little animals. But what it turned out was my collaborator was referring to rather more ferocious cat species. And I got some fecal samples from multiple cat species, including cheetahs, lions, jaguars, all of these collected from Dr. Lee Hagee, who is a longtime collaborator with us and also an expert of bile acids. And our focus on working on this data set was to try and discover new bile acids. We won't be talking about that, but we'll be going through how we can use GNPS Dashboard to look at data that more interactively. So before that, a very quick overview of what GNPS Dashboard is. So this is a collaborative interactive web application, much akin to, let's say, using Google Docs, where you can open a Google Doc and multiple people can collaborate or work on that at the same time. And GNPS Dashboard was developed with a similar motivation in mind to facilitate more interactive use of LC-MS data with many people working on it at the same time. We have the link for this on the slide and also on the tiny URL document that you may have opened. So what is GNPS Dashboard and how you can use it? So GNPS Dashboard, as I mentioned, is an interactive data analysis and exploration web-based application. It is integrated to the GNPS ecosystem, which means that if you are running any of your jobs on the GNPS ecosystem, there are links provided in those downstream analysis tasks from which you can directly go into the GNPS dashboard. In addition to that, you can also import data from various data sources, including in the public data resources like metabolites, metabolomics workbench, which I saw many of you answered in the poll as using your preferred database for depositing data. You can also use GNPS Massive. And for the proteomics, you can also use Pride and Massive in importing your data to the GNPS dashboard. In addition, if you have some data sets that are not publicly deposited yet, but they are retained in your private repositories, you can also upload raw data as well as MZML converted files by a drag and drop feature directly into the GNPS dashboard. And the downstream analysis from this would be you can launch various GNPS-based analysis as well, like mass searches, which Simone will be talking to you about, specifically the microMASST. You can do GNPS classical molecular networking, feature-based networking. In addition, you can also share these URL links for each of these analysis that you perform on the GNPS dashboard with your collaborators, either privately or even you can make these public in publications to facilitate even review process in sharing some of your data and analysis. We have the link for this paper. It's been published, and you can click on that to read more about the GNPS dashboard ecosystem and how to navigate that. But from now, we'll move into the interactive section of the workshop. And for this, I will try to go as slowly as I can to make sure that all of you are able to follow along. But in case you aren't, then please feel free to stop me or post in the chat and I'll take a break or help you around there. So for this, I'm going to stop sharing and I'll go to the interactive where I will actually be doing it and you can just follow along with me. So I will be stopping right now for the sharing my screen with the actual dashboard itself. Okay, so let's go there. Okay, so yes, were all of you able to click on the link, or maybe I don't know if Simone, you can also share. Oh yeah, I see that on the Slack on the chat already. So I'm assuming most of you may have reached a page similar to this, which is the Dataset Explorer. We are not in the dashboard yet, but this is the GNPS2 Dataset Explorer, where you can select files from any publicly available data set to transfer it or import it to be visualized in dashboard. Is anyone not on this page? Okay, so I'm thinking everyone is on this page. By default, there would be a massive ID or the massive ID of a data set already inputted, but we are going to add the massive ID for our data set, which is the MSV00 or I'm going to put it on the chat as well so that you can copy it. This is the massive ID for the particular cat data set that I mentioned. Okay. And once you have that entered, which is the massive ID with 93073, you will be able to now see at the bottom all the files that is contained within this data set being populated. So you'll see files such as A1, QE2, A2, which are IDs for the samples within this data set. The metadata is available, but if I to say which particular species this file is from, and so it happens the A1 is from a cheetah. So we will be looking at the sample today from a cheetah. So once you have on this page, you can click on peak/A1QE2, as you can see on my screen. So this is the file that we will visualize on the GNPS dashboard. Now you can visualize multiple files as well. So you can click as many files as you want to visualize. But in the workshop, we'll only be visualizing the first file, which is the A1QE2. You can also select files at the bottom where it will give you a comparison. So if you want to look at, let's say, two files, you want to compare the EIC or you want to make the mirror plots, you can also select at the bottom. And also the files that you select on the top, at the bottom, there is a window where the UZs for that particular files are also populated. So you can always copy paste this for multiple files that you select for any downstream analysis. But for us, we will be clicking on this tab over here where my cursor is, which is saying to visualize the one file in GNPS2 dashboard. And when you click on that, it's going to navigate you to the GNPS dashboard interface right now. So I'm going to wait for a few seconds just so that everyone is able to get to this page. And if not, then please, you can unmute and just say, or you can post on the chat as well. Okay. So I'll assume that we all are on the same page and we are at the GNPS dashboard now, where the GNPS UZ should be populated now with the UZ of the file that we are interested in looking at, which is the A1QE2. And now I'll explain briefly what each section of this dashboard is and what information it's going to give you. So the first part, of course, was the data selection part, where it is populated with the UZ that you selected. The second part over here is the viewer options, where my cursor is, where you can interactively work around and click to see if you want to change any visualization. For example, if you don't want to look at the MS2 markers, you can switch it off, or you can turn it on to look at the MS2 acquisition events throughout your runs. You can even select feature finding if you want, and you can also look at overlay, which is if you have multiple files selected in the dataset browser. The second part, it also gives you if your file is now ready for visualization. So in many of your cases, if it's a file that is taking time to load, you may see this loading, and then when it's ready for visualization, it's going to turn green and tell you that now it's ready for visualization. The next part in this page is the data exploration, which is a heat map here of retention time and M by Z to give you an idea about at particular retention time, what is the intensity or abundance of the molecules that you're detecting. And the blue markers over here are the events where the MS2 acquisition was triggered. And you would essentially use this to see how your data looks like, your data collection looks like, how many MS2 events were triggered, and the distribution of that as well. And below that is the total ion chromatogram, where it shows you the TIC of your data set. And you can also zoom in and click around the peaks to see. And then there are interactive panels over here that you can download the plot as well. You can zoom in or you can zoom out based on the visualization that you want to do. And I'll take a little bit of pause here just so that you guys can ask any questions if you have with whatever we've done so far. Okay. If not, then the next part is actually going into trying to look at data, like look at specific molecules that you may be interested in this particular sample. Now, for our case, as I mentioned earlier, we were interested in looking at some bile acids in these cat poo samples and see if what is the distribution and how they are present in these cat samples. So one of the bile is the bile acid, which is the colic acid conjugated to leucine, that was discovered in the Dorstein lab in 2020 by a former postdoc in the lab, Rob Quinn, who's now a professor at Michigan State University. And he was able to show them being present only in mice that had bacterial population and absent in the mice that were germ-free. So in those of you who are on the slides right now, you can probably see the M by Z, or maybe I can again post it. Oh, there we go. It's already on the chat. So the 506.384, that is the M by Z value for the leucine conjugated to colic acid. So if you populate it over here at the XIC M by Z, it's going to create the extracted ion chromatogram for that particular molecule. Now we can also play around and define our tolerances. Now this data was acquired on a Q-Exactive. So I'm going to change the tolerance to 10 ppm, but you can change it based on your data set and how the data was acquired. By default, it's going to give you the area under the curve, but you can change any of the parameters that you want. So it's interactive. Feel free to like click around and change different parameters and see how the visualization changes, or if there's specific that you can do. You can also change the rendering options based on if you want to download it as an SVG or a PNG, and you can download these plots as well. So for us now, within a 10 ppm threshold, we have the extracted ion chromatogram created here for our colic acid with conjugated to a leucine. And the red marks on this peak are all those events where the MS2 was acquired for this particular molecule. Now, if you want to look at the MS2 spectra, so you can click on the apex. You can click on any of these red crosses to get the MS2 at that particular time. But I'm going to click on the apex now to get the MS2 spectra for this particular molecule. So this is at the bottom panel. Now this is populated with the MS spectra for the leucine conjugated to colic acid, with all of the different fragments arising from the steroid core and the 86 from the leucine itself. Now, over here, there are at the bottom where my cursor is, there are multiple view tabs where you can perform further downstream analysis that is compatible with GNPS Dashboard. One of them, which can be interesting, is or important for you all, is the GNPS library matching. So if you were to try to see what spectral match do you get from the library for this particular spectra, if you click on this, it's going to show you what were the matches that it recovered from the GNPS library. And for this one, we already knew that it was a leucine conjugated bile acid. So you get the spectral match to the leucine conjugated CDCA. Also, you have matches to isoleucine because just MS2 spectral matching doesn't differentiate between the isoleucine or the leucine isomer. And then there are some matches from the suspect library. So you can filter through all of these to get annotations to what your molecule of interest could be. The other thing that you can do over here is the tab that says Massive KB Library, where you can perform a fast mass search or a search for your query spectrum, which in this case is this spectra here, to see in which other data sets was it found in the GNPS massive as well. So I'll not go more into this because Simone is going to touch upon the microbeMASST, which is similar to what FastMASS would be, but in the microbial domain. And the last thing that I'm going to touch upon in this part of the workshop is looking at the view metabolomics UZ. So UZ is the universal spectrum identifier. Some of you may be aware of it. And each spectra has a UZ associated with it. So does this particular MS2 at the scan 2471. So if you click on View Metabolomics UZ, it opens the visualization of the MS2 spectra. And you can always copy the link here and open it in a browser. You can share it with your collaborators or add it to your papers as well. And in addition to that, you have the Spectrum UZ over here, which is composed of the massive ID from which this data is. Then it's composed of the file name and the scan, which corresponds to the MS2 spectra of the bile acid. So for the next part of the workshop that Simone would be conducting, you all will be needing this particular UZ. So we can post it on the chat, it's already there. And this UZ is what you can then use to search anything about this particular spectra in data sets, in microbial reference databases, and other downstream analysis. So yes, with this, I think we are to the end of the dashboard. But yes, if you have any questions, please feel free to ask.
I have a question.
Oh,
I
hey,
think
Arpana. Yes.
Hey, how's it going? I think I did something wrong, so I tried to. The first time I was following you, the EIC looks very different. There's no peak. And then I tried to redo my steps, and then the EIC plot says grouped per MZ, so it looks different on both cases. So I'm not really sure what I did wrong.
So, so you're saying in your case you grouped it by MZ, which is what the default is by default on this interface. Do you mind sharing your screen if you want? Then I can see how the visualization is different.
Sure. Okay, let me hold on. These two. Okay, so I'll show share screen. Share. Okay, so this was the first attempt when I was following you. So I put in the mass here.
I see. I think
It's
your
the same
plot is
file.
zoomed. Your plot is zoomed in, so maybe you
Oh.
can zoom out. Yeah, if you click on the
No,
no, that one, the other, yeah, the one after that.
This one.
Okay.
No, yeah, it looks different. And so now, then I tried to retrace my steps, and then I did the same thing, same file. MZ is there, and it looks like this. There's no red little dots, and the peak looks different. I don't know what I did.
Let me see. Can you scroll up again? The
Yeah.
first thing is you can maybe remove it from the UZ2 because we are just looking at, I don't think that's making a difference, but you can remove it from GNPS UZ2. Yes, here. So this is if you want to compare, you can always use two data files to compare. So in that case, you can add it to GNPS UZ2. The other thing I would do is if you scroll up in the tolerance ppm, you can change the tolerance unit to ppm. Now it's a very broad window. Yeah.
Oh.
Okay. And then I think if you scroll down,
Now that looks the same. Yes.
Yeah.
Oh, that's interesting. Because I didn't change, I didn't, when I clicked on the file, I did, which one did I don't remember. But that makes sense now. Definitely the tolerance unit makes an impact on it. Thank you.
Yeah, no worries.
Hey, sorry, Ipsita. So when you add two files together, that means that we don't get those little red dots across the
No,
spectrum?
you should still get the red dots. You'll have to select which file you want to see. So in the visualization window, let me share my screen again. Okay, so here you can always put GNPS UZ1 and UZ2. And in this selection file, now it's one, but if you have two, it's going to show you both files. So you can select which file you want to see on this window. So you should still, yeah. And over here, you can also do show UZ to LCMS map. For me, now it's turned off. You can turn it on, and then it's going to show you for both. So now you would have two plots for UZ1 and UZ2. Okay. Is there any other questions?
I have a question. So I don't know which step I forgot to click, but in my web browser, I didn't see any hits under the GNPS library.
So okay,
yeah,
so
I saw you get 42 putative hits, but I didn't see any hits in my
So
page.
you'll have to make sure that you have selected the particular MS2. So is your MS2 window now populated with the scan 2471?
I get 2482.
So 2482 is no
Okay,
2482.
I got the 71, 2471.
And then
Yeah.
I think you should. Do you see that now?
Oh yeah, I see it.
Okay.
Okay, thank you.
Surrender in the chat also wrote, please repeat again. Which part specifically? You can write it in the chat if you don't want to unmute yourself.
Hi, I haven't get anything. I think I forgot. I also forgot to click on some part.
Oh, I think in the interest of time, I don't think I can repeat everything, but you can. We have all the steps mentioned in the document or in the slide. Each step with with detailed instructions on where to click. So you can maybe give that a try, and if not, if you do have time at the end of the workshop, please feel free to stay back, and then I can show you again as well.
May I follow up my question about the GNPS putative hits? So when I click into it, how could I benefit from this annotation? So I didn't see any structures or metabolite name.
Yes, so right now this is not populated with the smiles, which is what you can use to get to the structure. But what you can do is, so here all you get is the compound name, right? So it's going to tell you that it's a leucine conjugated to a quinodeoxycholic acid, or it's isoleucine conjugated to another bile acid isomer. So you would get the names here, which you can always convert to structures later on. Otherwise, the other thing that you can do is you can copy this over here, which is the GNPS library accession, the CCMS library ID. So all the spectra and the GNPS library is associated with the CCMS ID. So you can select that. And then when you get that, and you can use this ID to search in the GNPS spectral library, which I can put the link here in the chat. And then over there, it'll show you the structures for those that have smiles. Yes.
Thank you so much.
Yeah.
So a quick question in respect to these UZIs. I imagine they're like unique spectrum identifiers. That's what it stands for. I
Yeah, you're correct. Yes.
So what information do those entail? So or encode? Do they encode just a spectra, or do they have any additional metadata, like how it was acquired, which retention time, which column was it used, which parameters were it used? Like, does it encode all that information, or is it much more minimal and basically based?
I see. Yeah, that's a good question. So the UZ itself, the way it is designed, as you can see here, it doesn't encode those information. It gives you the ID of the data set. It gives you the file name. And if it's a spectra, it's going to give you the spectra ID. But there are ways that you can use the UZ to get further metadata information. So one of them is using the MASST searches, which Simone is going to talk about in the next part. But the other thing that you can do, if you want to know more about this particular data set, like you received a UZ from someone and you want to know what this file or the spectra is from, right? So you can always copy this massive ID, or in your case, Metabolomics Workbench, or whatever unique ID for that data set exists. And if you click that, and in this case, this is a massive. So if I go to massive, and you can search for this particular massive ID over here, and then it's going to give you the information, whatever was deposited by the people submitting this data set. So in this case, it was me. And here you can get information about, okay, what the extraction was, what column it was used, and what mass spec information or instrument was used. So this would be at the prerogative of what the users submitting this data have deposited. The other thing is, if now this data set has a metadata, so you can browse the metadata. So there would be a metadata file. Not all data sets have that. Some data sets also for us, we have many that is compatible with Redo, which is another interface where again, using particular UZs or massive ID, you can get metadata information for those as well.
Perfect. Thank you. And thank you, Simone, for the paper link.
Yes.
Awesome.
Works also for proteomics data. Yeah, maybe in the interest of time, we should move on.
Yes.
So let me share my screen. So as Ipsita nicely, as Ipsita was mentioned, like in the PowerPoint, you will be able to find like click-by-click instruction of what she has done. So if you were not able to get to that result, you will be able to do it by just following the slides, and then you will be able to see this the presentation again on YouTube. So the idea is that in this case, we are obviously working with the molecules that we already know of. That is a microbial metabolite, is a bile acid, right? Conjugated to isoleucine or leucine. But the idea is that maybe you are working with your own data sets and you are finding this peak, these scans in particular of a molecule that you have no idea what it is, and maybe you are interested in understanding if this molecule is of microbial origin or not. So what I'm going to show you next is basically how to use microMASST. That is a tool that we have recently developed that allows you to search for your own specific spectrum of interest against our curated repository of data that has been acquired exclusively from microbial monocultures. So that's will help you point out if the molecules that you are investigating, that can be a completely unknown molecule, has already been observed in monocultures of bacteria, and that may be suggesting you that actually that it's a real molecule, it's a microbial molecule, and then hopefully will help you further develop your own research and validate your observation. Giving the time, I don't have, I will not go through how we build microMASST. We already gave, I already gave a talk a couple of months ago on all the rationale and how we built it. There are actually several YouTube videos on YouTube about the presentation of microMASST. So I've just linked one of them, like a longer one where we have a lot of discussion. So you can click on this link and then maybe watch it later on. We also have published microMASST a couple of months ago too. There is a link to the paper. So you will have to read this offline later. So, because I want to give you a hands-on on how to use microMASST. So if you can all please click on this link, you should be able to open the standalone web app of microMASST that should be looking like this. So I'll give you just like a couple of seconds to upload this. So in our cases, we want to search for the specific scan that Ipsita was talking about. So I'll just copy it here. It's in the chat. So you can either through the standalone web app that you can see here, you can either search for the spectrum using the USI. So if you are able to get it by having your data deposited online, or actually, if you are more traditional, you can also just copy paste your fragment ions, the precursor mass, and then set up different parameters for the search. In our case, we will just keep the standard search parameters that we already provide. So this is the tolerance for both the parent ion and the fragments, cosine threshold of 0.7, and a minimum matches peaks of 0.3. So if you are using a Spectrum USI, you will have to click on Search microBUS by USI. Otherwise, if you are putting your data, your fragment ions and everything manually, you will have to click Search by Spectrum peaks. So if we click search on microMASST by USI, and we just scroll down, in a couple of seconds, we should be able to get results. So please let me know if you can get to this point. I'll just give you a couple of seconds in case. Just remember that you just have to copy paste the USI that I've put it in the chat. Here in the Spectrum USI, click search by microMASST by USI, then scroll down and you will be able to see an interactive tree. So the idea is basically is that we will search your spectrum against all this data acquired from microbial monocultures, and then the output information of the matches is actually plotted in a nice way. So it kind of help you understanding if there is any relation actually to the taxonomy hierarchy that it's present in the microbial world. So you can see here, you can zoom a different level. We have several matches. You can see the different pie charts. You can see that the pie chart is actually describing how many matches are found in the total number of samples that are available for that specific taxon. So in this case, if you put your cursors on top of it, you will be able to see the scientific name of the bacterium, the NCBI ID, the rank of the strain, and then you can see that one samples out of the 11 samples that are present for this bacterium were found to have that specific spectrum matching. So probably that this bacteria is actually able to conjugate the deoxycholic acid isomers to isoleucine or leucine. And you can see that we have several matches for other bacteria. As I was mentioning also in my previous talk, you can collapse a different level. So for example, let's say you want to show only some genus level, and for other you want to show the strains, you can do it. You can use here the parameters also to show, let's say, only at phylum level, or you can just go up to family level, genus level. You can play with it as much as you want. You can see here, for example, for Collinsella, we have 2 matches out of the 11 samples were present for the specific taxon. So you can see that there are other 3 tabs present here that have been generated. So when you click on it, actually it opens up and you will be able to see different tables. Here, it's actually very similar to what Ipsita was describing before. While we search your MSMS spectrum against our repository of microbial data, we also search it against the GNPS library in order to help you probably giving a putative annotation of the molecules that you are looking for if you have no idea what you are looking for. In this case, obviously, we looked for like a molecule that we already knew. And you can see that there is a very high cosine score matching. So this is just a matching of the MSMS spectra and a high number of matching peaks. So we have a certain confidence in saying that that specific spectrum, it's probably a conjugated form of DCA with isoleucine or leucine. And this happens with all kind of spectrum that you have. Obviously, if we don't find any spectrum matching in the library to your spectrum, this tab is going to be empty. And this tab can also be downloaded both as like an XCLS or CSV file. You can see also different numbers of entries, and that works. This applies to every tab. So if you are not able to open this, please let me know and I'll stop and we can discuss about it more. But you can also click on dataset matches, and here you will able to see, let me open more matches. So you're able to see which scan in which sample for that specific taxon was actually found to match your spectrum of interest. And that gives you also a USI for that scan in that specific sample. And you can open the resolver and visualize manually, actually, the spectrum. So you can see here that there are several peaks matching, the cosine similarity, the parent mass are matching. So if you don't trust just the blinded match, you can also just like click on it and do a manual inspection. And this can be done for all the samples that are available that are found to find a match. You can all inspect them manually. As Ipsita was also telling you, it gives you also a link to the massive data sets where hopefully you will find more information on how the data was acquired, which column, and also you will find information on who deposited the data. So if you want to get in touch with that person, you can in order to get more information. And finally, there is a taxa matches that basically is just collapsing all the information at the different taxa levels. So you can see in this case that for bacteria, we have 20 matches out of the 45,000 samples that have been acquired from bacterial samples. And you can see this for all the different taxa levels. So can be phylum, can be order, family, genus. That's another way to visualize in a tabular form the output of microMASST. And finally, in the last tab, you can see the parameters that have been used to for the search. Finally, you can also try to visualize the tree with all the different matches that were actually not present. In this case, matched plus order will show you if you have one match in that specific species. It will also show all the strains that are available for in that specific species, but when they are white, it means that no matches was found. So you can explore the tree also in that way. You can also explore the full tree, but we have more than 40,000. We have 2,000 unique ID coming for like almost 60,000 samples. So it's a bit messy to just look in at that way. And all these the results are also HTML files are downloadable. So you can just download and then you can like take screenshot and put them in your publication. Obviously, in this case, we search for something that is known. As I was telling you, I want to show you like example. This is the example of when if you want to search for a molecule that you don't want to use the USI, but you can put in the fragment ions, their intensities, the parent mass, the precursor mass, and then click search by spectrum peaks, and it also work in that case. In this case, the spectrum was phenylalanine acid. Is there any question for that? I guess it is unknown. So all the information is also available for like point by point clicking in the slides, so you will be able to follow this later on if you are interested. And finally, since we are in the SODA meeting, I just want to briefly touch on this. Unfortunately, there will be no time to dive deeper into this, but this microMASST obviously allows you to search one spectrum per time, but some of the times you want to search maybe for 10 spectra or 50 spectrum. So if you use the web application, you will have to do it manually one by one, but we have ways to do it like programmatically and do batch searches. But you will have to be familiar with coding in order to do that. Here I put a link to the GitHub repo for microMASST that you can find here. Here there is a documentation, so if you are familiar with coding, I think it will be fairly easy to go through this and do it yourself. But basically, this allows you to search for multiple MSMS spectra by inputting either an MGF file or containing all the different spectra that you are interested in, or a CSV, TSV file containing a list of the USI with the spectra that you are interested in. It's fairly quick and easy to do. So if you are interested in doing batch searches, I suggest you to go through the GitHub repo, and then if you are stuck somewhere, you can get in touch with us. Here you can also find the link to the web apps. I've introduced microbeMASST today, but we have done it for different domains. For example, we also have PlantMAST, where you will able to search specifically molecule against a repository of curated data that was acquired only from plants. So we are doing a lot of different repos. So hopefully this is gonna help the different communities that are working with the metabolomics data set. So if there is no other question, I think we are at the end of our workshop.
Great, thank you so much for giving the presentation. Yeah, were there any more questions? I guess first over microbeMASST, and then if there were any additional ones over the dashboard. If not, or yeah, if not, we'll have this recording posted after we do some editing with and get permission, obviously. We'll post it on the Mana website, so if anyone wants to repeat these exact things, or also Simone, if you have any, and if you have any better, or not better recordings, but any other presentations you'd rather be shown or linked in there, I'll send an email asking for those as well, and we can cross-link those on the website too.
There are, so if you go on YouTube, and there are a lot of like tutorial that we have created through our lab. So if you search for GNPS, microbeMASST, and all the tools that we have developed, there are several workshops. Very good also is from the VMOL lab of Daniel Petras. They are doing these seminars every week about like workshop on how to use different computational tools. So if you go on YouTube, there will be a lot of videos. Just search for GNPS of microbeMASST. Also in the file, in the Google Doc attached to this presentation, I put several links for the documentation, the web standalone apps, the preprints of the papers, the form for requesting a GNPS2 account. So you should find good information also here.
Right. Thank you all. And if there's nothing else,
yes, the slides, there is a question. The slides are available, so you should have been able to scan the QR code or write down the tiny URL. Those will stay available. So even for people that will see these videos in 3 months on YouTube, they will be able to download the slides, access all the documents that we have provided. So those will stay there.
So, and one more request for the QR code.
Yeah, the QR code is this one. So this QR code will give you, let you get to the Google Doc, the document that there is links to the Google Doc itself, and also this presentation and all the other links. So you will be able to get this.
And with that, thank you everyone for joining us today, and thanks again to our presenters. And we have open slots for more workshops and meetups. So if you have any suggestions or anything that you'd like to see or host yourself, let us know. Either visit the website or fill out the forms. And aside from that, we'll see y'all next month for a SOTA meetup, and maybe we'll see y'all in Tampa in October. Thank you very much. Have a great day, everyone.
Thank you.
Hi, everyone.
Thank you all. Bye.
Thank you.